Lagrange's interpolation method. Okay, all of you keep a calculator with you. Okay, so interpolation. Interpolation is one of the very important techniques in numerical analysis. That is, suppose you have a few set of data points, like for example, taking the census. You know, we are all taking census. The government is taking census only in once in 10 years, like 1961, 71, 81, 91, 2001, 2011, like that, 2021, once in 10 years. Suppose you want to find the population of a particular region in between, say, suppose you want to find the population in Kerala at 2017, what will you do? So, to find the intermediate values, we will try interpolation methods. Okay, so if you have a data values at certain times, for example, say we have x values, y values. X values are like a 5, 10, 15, 20, 25. Y value, say this is 2, 3, 7, 9, 8, etc. Suppose you want to find what is the value of y at x is equal to, say, 23. So in that case, we will go for interpolation methods. Okay. So this is the advantage or application of using interpolation in numerical analysis. Okay. So in engineering, you have lots of importance in this, because when you to conduct certain experiments, sometimes you are restricted to find the data values at only certain values. Okay. So to find the intermediate values, you can try interpolation methods. There are lots of interpolation methods available in numerical techniques. Lots of methods are there. Here you are going to study two types. One is Lagrange's interpolation method, and other is Newton's forward as well as backward. Newton's forward interpolation method and backward interpolation method. Here I asked why to find y at 23 means it is around the later stage of the value. So here in this case we will use backward interpolation method. Suppose you need to find the initial value, like you want to find y of 8. So it was the beginning of this, then in that case you will use forward interpolation method. Okay, is it clear? When you are going to use backward interpolation method, if you want to find later values, the end values, you will go for backward interpolation method. And if you need to find the initial values, that is the values at the beginning stages, you will use for Newton's forward interpolation method. Okay, that is the case for Newton's. I am clubbing both the terms because I have to finish these two methods together today. Okay, so when you are asked to find the beginning values, you will use Newton's forward interpolation method. Then if you are asked to find the end values, towards the end values, you will use Newton's backward interpolation method. Now we are telling about what do you mean by an interpolation. Okay. Okay, suppose you have certain values like y x naught, y naught, x naught, y1, x1, y1, x2, y2, etc., xn, yn, and it represents say values. Say y1 means it is f of x naught. So you can say y naught is equal to f of x naught. Y1 is equal to f at x1. Like that it will go. Okay, so this is the relation connecting y and f of x. So you can find some unknown function. Mostly it will be a polynomial. So y is a polynomial. So y is equal to f of x is a polynomial at a limited number of points, and which are independent, limited number of points, say x1, x2, etc. So x is an independent variable, y is the dependent variable, x is the independent variable, whereas y is the dependent variable depending upon x. Now, it is often required to estimate the value of that function at one or more intermediate values. As I said earlier, we have to find one or more intermediate values of x that lies between the given region values, given values. In between, you will find lots of more data from using interpolation method. This technique of estimating the values of a function at intermediate values, that is very important. the method of estimating the value of a function at intermediate values is called interpolation. If you are going to find the values exterior of the given data intervals, that is called extrapolation. That is another technique, extrapolation. You are not going to study extrapolation here. That is another, that is for exterior cases. This is for interior intermediate values, you will be using interpolation. The other one is extrapolation. Okay. Now, types of interpolations. So, first, the simple technique is linear interpolation. As the word indicates, you know. What do you mean by linear equation? You know it is a first degree equation. Same thing here also, it will be a linear expression. So, linear interpolation is a function which is expressed in linear terms. So, a simple method of interpolation in which the points are assumed to be connected by line segments or straight lines. So, that is called interpolation. So, it will be a first degree polynomial in the given independent variable. Now, however, many of the practical situations, we will not be able to find a linear relationship between the data points. So, in that case, we have to go for polynomial interpolation. Polynomial interpolation means we are connecting that with more than higher degree variables. So, if the degree of the given variable is more than 1, we will go for polynomial. So polynomial means second degree polynomial. It is quadratic equation, cubic equation, third degree polynomial, and higher orders. Okay. So when you get higher order equations or functions, you will be getting polynomial interpolations. Okay. So both are frequently used in numerical interpolations. Okay. So this is an expression graph for a linear interpolation. So look at this. Here there are lots of data 0, 1, 2, 3. So this is y of 0 is 0 here. Y of 1 is in the top value. I am highlighting it with the red color. And y of 2 is this upper value. And y of 3 is the dotted lines. Okay. You can see that they are connected by straight lines. You can see the straight lines connecting these data points, isn't it? So they are interconnected by straight lines. So hence it is called a linear interpolation. So this is a linear interpolation, and it is not often possible to find linear interpolation. So we have to, many times we have to opt for higher degree polynomials or polynomial interpolations. So look at the second figure here. So here the data are connected by smooth curves. Okay, you can have it as a smooth curves, but you can freehand we can connect these by curves. So it is called a polynomial interpolations. When the data points are connected by curves, you can say it is a polynomial interpolation. So you got the difference between linear interpolation and polynomial interpolation, isn't it? So linear interpolation means the values or data are connected by straight lines, whereas for polynomial interpolation, they are connected by curves. And the mathematical expression is for linear interpolation, the polynomial will be a first degree polynomial, whereas for polynomial interpolation, it will be second degree or more. It will be higher degree polynomials. Okay. Now, this is a very important theorem which we use to work out problems. So, if you have n plus 1 data points, say n plus 1 data points, there is exactly one polynomial. The polynomial you are going to get is a unique polynomial, Pn of x, of degree at most n. Thus, the maximum value of the polynomial, the degree will be n, which satisfies Pn of xi is equal to ya. Suppose you have 4 data values with you, say x0, x1, x2, x3. So, similarly, correspondingly, y values y0, y1, y2, y3. So, there are total 4 data points. Okay. So, according to this theory, the resultant polynomial will be a cubic polynomial, isn't it? Third degree polynomial. So it will be one, the order will be 1 less than the number of data points. That should be remembered. Okay, you have to keep this in your mind. If there are n plus 1 data points, are you following? If there are n plus 1 data points, the resultant polynomial Pn of x will be of degree at most n. It will be of degree at most n. At most n. Okay. So if there are 7 data points, So if there are 7 data points, so what will be the degree of the corresponding polynomial? It will be a 6th degree polynomial. You got the concept? So this is the theory we are using here. So if there are n plus 1 data points, the resultant polynomial will be of degree maximum n. Okay. So Lagrange's interpolation method. Suppose you have n plus 1 data points here, say xi, yi, and yi are the values of some unknown function y is equal to f of x. Then Pn of x is given by Pn of x is equal to L naught x into y naught plus L1 x into y1 plus L2 x into y2 plus etc. Ln x into yn. So in effect it is called sigma over I varies from 0 to n Li of x into yi. What is this L naught? So what is this Li? So look at this. So L naught is, Li is x minus, this you have to make sure that you are learning it properly. This is a symmetric function, x minus x naught. Similarly, correspondingly in the denominator, it will be xi minus x naught. So the I is the suffix which is connecting here. X minus x naught by xi minus x naught, then x minus x1 into xi minus x1, etc. x minus xn by xi minus nn. Or you can say that, suppose you are going to find L1 of x. So this will be like x minus x naught into x minus x2. You are skipping xi here, etc. X minus xn, the whole divided by xi x1 minus x naught, x1 minus x2, etc. x1 minus xn. Okay. Now what about L5 of L2 of x? L2 of x. So L2 of x means x minus x naught into x minus x1 into x minus x3, etc. up to x minus xn. So here, not here, we are skipping the term containing x2 in the numerator. Now what about the denominator? Denominator will be x2. Instead of x, you have to put x2. x2 minus x naught, x2 minus x1, etc. What will be the third term? x2 minus x3, etc. Go up to x minus xn, x2 minus xn, depending upon how many data values are there. Suppose you have only values up to 3, x3 very low, then we will go up to x3 only. Okay, so depending upon the number of values you have to choose. Okay, suppose this is a data having 4 values, say x0, x1, x2, x3. So in that case, you can truncate up to this. So that we can truncate here. It will we can skip these 3. Okay, so this will go up to this only. So this is how we write the function Li of x. Now multiply this or each term by the corresponding y terms. What is y term? So in corresponding to each x naught, you have a y naught. Multiply that y naught here. Corresponding to each x1, you have an y1. Corresponding to each xn, you have yn. What is the relation between xi and yi? Yn is equal to f of xn. So this polynomial is called the Lagrange's interpolating polynomial for the given values. This polynomial is called the Lagrange's interpolating polynomial. So I will quickly go through the problems. So I have shared this notes in your. So look at this here. Here this x for Li, x minus x naught, x minus x1, etc. Here in between we have skipped this I term containing I in the numerator. x minus xi is not coming in the numerator. So whatever be this index corresponding to this L, we will skip that. Okay. So etc. up to x minus xl. Similarly, in the numerator, all the terms are containing x star terms, factors starting with xi. So we will be forced to skip xi minus xi term in the denominator. So we have to make sure that we are doing this properly and multiply each li. ഇവിടെ xi വരുവാണെങ്കിൽ we will multiply with yi. Okay. So L1 into y1, L0 into y0 plus L1 into y1 plus L2 into y2 plus etc. Ln into yn. Like that we will do. So look at the problem. This problem ഒന്ന് നോക്കിക്കേ. So using Lagrange's interpolating polynomial, estimate f of 1.5 for the following data. Consider, okay, so x is equal to 0, 1, 2, 3. So how many data values are here? Say here it is 1, 2, 3, 4, isn't it? So put it as, say, keep this as x0, this is x1, this is x2, and this is x3. Correspondingly, we have the y values. Y is equal to f of x. So the first one we will put it as y0, then y1, y2, y3. Okay, so x0 is 0, x1 is 1, x2 is 2, x3 is 3. It need not be unique numbers, it can be any numbers. They need not be equally spaced also. Okay, so we can have distinct values, irregular values, anything you can do, 0, 1, 5, 10, etc. you can choose. Now y values, y0 is 0, y1 is 0.9826, y2 is 0.6299, y3 is 0.5533. Okay, now here we have, look at this, x0, y0, x1, y1, x2, y2, x3, y3. You have found all the data points. Since there are 4 data points, what is the degree of the interpolating polynomial? The degree of the interpolating polynomial will be 3 or less. Okay, so 3 or less. Look at this. So how will you find L0 of x? L0 of x is formula എന്തായിരുന്നു? L യുടെ formula ഉണ്ടല്ലോ, x minus x0 into x minus, ഇവിടെ x minus x0 വരും, x minus x1. The first one will be your formula ഒന്നുകൂടെ എഴുതാം, that then will it be clear to you. What will be L0 of x here? ഈ particular case it is എവിടെ എഴുതിക്കോണേ, x minus x1 into x minus x2 into x minus x3, the whole divided by, what is the denominator? x0 minus x1, x0 minus x2, x0 minus x3. Okay, so you are getting this as x minus x1 is 1. So x minus 1 into x minus 2 into x minus 3. Got it? What about the denominator? Again, we have to start with x0 minus xi. So x0 is 0 minus 1, 0 minus 2, 0 minus 3. It is not necessary that you have to simplify each and every term distinctly. You can do in a single stretch also, but make sure that you are not you are doing it correct way. Okay, don't commit any mistakes while simplification, during the simplification. Okay, so look at the numerator. Numerator is a cubic degree polynomial here. You have to simplify that. If you are, suppose you are asked to find an interpolating polynomial, you have to simplify it. Otherwise, you can just put the value. You need not waste your time for your exam point of view. Okay. Here in this question, you are just asked to find f at 1.5. So you need not worry for in simplification and ending it in wrong results. You can just put it the values, then substitute and find the final answer. That is enough. Okay. So 1 by 6. How we got 6 here? 0 minus 1. And again for the denominator, you have to be very careful in putting the sign. 0 minus 1 is negative here. Again 0 minus 2, 0 minus 3, all 3 negative. So it will be a negative, odd multiple of negative signs. So minus 1 by 6 into x minus 1 into x minus 2 into x minus 3. You need not worry about simplification here. Now L1 of x, L2 of x, L3 of x. Okay, so you have 4 terms, L0, L1, L2 and L3. Correspondingly, you have to find L0 at 1.5 because you are asked to find y at 1.5. Then L1 of 1.5, L2 of 1.5, L3 of 1.5. Find all the values, and substitute in the given polynomial. So how we are going to get is P3 of x is equal to L naught x into y naught, L naught x in L plus L1 x into y1 plus L2 x into y2 plus L3 x into y3. Okay. Now P3 at you have to just find the value. You need not worry about the polynomial. Sometimes it may be asked to write the polynomials. In that case, you have to simplify and write the polynomial. Otherwise, you can skip that and simplify this. So P3 of 1.5 is substitute here L naught of x into y naught. Y naught here is it's given. What is the value of y naught? Y naught is 0 here. 0. Y1 is this. Y2, Y3. Substitute here and you are getting the final answer. This is how we are going to use Lagrange's interpolation method. Okay. Any doubts? Now look at the question. Here you are asked to find the second question. Find a unique polynomial P3 of x of degree 3 or less. Find a unique polynomial P3 of x of degree 3 or less, the graph of which passes through the points these. So you are not given any data points like x naught, y naught like that. You are given that a polynomial is passing through these points. So in this case, you have to choose this as x naught, y naught, this is x1, y1, this is x2, y2, x3, y3. Choose these values and pinenda cheyande choose these values and substitute in this L0, L1, L2, L3, etc. Okay. Now, so you got L3 of x. Now P3 of ഇവിടെ ഒരു ചെറിയ ടെക് ഫയൽ ഒരു ടൈപ്പിംഗ് എറർ ആണ്. ഞാൻ ഇത് കുഴപ്പമില്ല, ഇത് നോക്കിയാൽ മതി. സ്റ്റാർട്ട് ഫ്രം ദിസ്. ഇതോട്ട് നിങ്ങൾ ശ്രദ്ധിക്കുക. So P3 of x is L0 x into y0 plus L1 of x into y2 plus so P3 of x, I will write it here. P3 of x is equal to L0 x into y0 plus L1 of x into y1 plus L2 of x into y2 plus L3 of x into y3. So this is a cubic degree polynomial. Since there are 4 data points, the resultant polynomial is a third degree polynomial. So look at this. So here you have got third degree polynomial. Substitute all the values. But this is the method. Okay. So you will be having Pranyan. I have shared the notes and I have given problem. This is your note to share it. You can go through that. Okay. So this is the Lagrange's interpolation method. So next one I will quickly go through is Newton's forward and backward interpolation method. So as I told you, this is also one of the important interpolation techniques. And to find the initial values, that is the values in the beginning of the given data values, you will be using Newton's forward interpolation method or forward difference method. When you are asked to find the values in the towards the end of the given data, you will be using backward difference method or backward interpolation formula. This is applicable to data points with equal spacing. Look at this, very important. How will you distinguish between whether we have to choose Lagrange's interpolation method or Newton's forward or backward method unless it is specified? That is by this techniques. If the given data values are equally spaced, we have to stick on to Newton's forward or backward. If they are unequally spaced, go for Lagrangian method. Is it clear? If the values are unequally spaced, not equally spaced, go for Lagrangian method. If they are equally spaced, go for Newton's forward or backward. So here they are equally spaced means x1 equal to x0 plus h, x2 equal to x0 plus 2h, or etc. xn is equal to x0 plus nh. Like our arithmetic progressions you have studied in your school classes. So x1 is equal to x0 plus h, x2 equal to x1 plus h. That is same as x0 plus 2h, like that. x3 equal to x2 plus h. That is equivalent to x0 plus 3h, like that. Okay. So they are interconnected by a sequence like this, arithmetic progression bole. And what is this h? H is called a step size. A increase in the increment ആണ് h. എന്തെങ്കിലും ഡൗട്ട്സ് ഉണ്ടെങ്കിൽ എന്നോട് ചോദിക്കണേ. ഞാൻ കുറച്ച് ഇന്ന് തന്നെ തീർക്കണം എന്നുള്ളതുകൊണ്ട് ഞാൻ എത്ര സ്പീഡായിട്ട് പോകുന്നത്. യു ഹാവ് ടു സ്റ്റോപ്പ് മീ അറ്റ് എനി പോയിന്റ് ആൻഡ് യു ക്യാൻ ആസ്ക്. For any set of data points xi, yi, the first order forward differences are given by delta yi. Delta yi equal to yi plus 1 minus yi. The second order forward differences are given by delta square yi. That is, ഈ തിയറി കാണുന്ന പോലെ അത്ര ഭീകരമായിട്ടുള്ള കാര്യമൊന്നുമല്ല. ഇറ്റ് ഇസ് വെരി ഈസി ടെക്നിക്. നൊട്ടേഷൻസ് യു ഹാവ് ടു നോട്ട്. Delta yi plus 1 minus delta yi, and kth order divided difference will be just one less. That is, delta k yi will be delta k minus 1 yi plus 1 minus delta k minus 1 yi. ഞാൻ ആ തിയറി ജസ്റ്റ് ഒന്ന് പറഞ്ഞിട്ട് പ്രോബ്ലം വരുമ്പോൾ you will be able to find out easily. Okay. So look at the table. I values, yi values. Delta yi, delta square yi, delta cube yi. And how will you check, fix how many orders you have to go? So here there are 4 points, 0, 1, 2, 3. That means 4 data points. Then you have to go up to third order. Okay, one less. Then you can stop. Okay. So the method is first write a table, fix a table like this. In the first column, write the index x values. You can either write the x values here. Then okay, you can choose x values, right? X values here. ഇവിടെ xi എടുക്കാം, ഇവിടെ yi എടുക്കാം. Okay, ഇവിടെ xi എടുക്കാം, ഇവിടെ yi എടുക്കാം. Now xi value 0, 1, 2, 3, and y values are significant here. y0, y1, y2, y3. Now delta yi, I told you it is the first order differences. So delta yi means delta y0, delta y1, delta y2. Delta y0 is the difference of the intermediate values. Say y1 minus y0. That should be coming here, and make sure that you are writing in the middle in the second column. For second column, y0 in y1 in between when write here. So it will be, you will be getting an idea of how it is going. Okay. But clear out in between when that. So second value is y1, y2. So delta y index y0 എന്ന് പറയുമ്പോൾ forward ആണ്. You are going one and forward and coming back. y1 minus y0. Delta y1 is one and you are going stepping one and forward and coming back. y2 minus y1. Delta y3 is going one and forward, that is y3 minus y2, and writing in between this. അപ്പോൾ നമുക്ക് ഇവിടെ notation നിങ്ങൾ just values മാത്രം എഴുതിയാൽ മതി. Delta square y0 means delta y1 minus delta y0, that is writing here, and in between this ഇതിന്റെ middle value വേണം എഴുതാൻ. And delta cube y0 is delta square y1 minus delta square y0. You got a point? This is how you are writing this. Now the Newton's forward interpolation formula is this. This is also called Gregory's method. The Gregory's interpolation formula theories വരാറുണ്ട്. പക്ഷെ നിങ്ങളുടെ സിലബസിൽ you have to stick on to Newton's forward difference interpolating formula. There are n plus 1 data points. They are equally spaced with the condition xi is equal to x0 plus ih. Then the polynomial is polynomial. നിങ്ങൾ കാണാതെ പഠിക്കണം എക്സാമിന്. You have to by heart this. Pn of x is equal to y0 plus u into delta y0 plus u into u minus 1 by 2 factorial into delta square y0 plus etc. u into u minus 1 into etc. u minus n minus 1 and u minus of n minus 1, that is u minus n plus 1 by n factorial into delta raised to n y0, where u is equal to x minus x0 by h. What is x0? The initial value here. E x0 ആണ് ഇവിടെ വരേണ്ടത്. Okay. So u is equal to x minus x0 by h. This is a forward case. Same thing ഞാൻ backward പറഞ്ഞിട്ട് പ്രോബ്ലം ചെയ്യാം. അപ്പോൾ പെട്ടെന്ന് ഇതങ്ങ് മനസ്സിലാവും. So ഇവിടെ ഡെൽറ്റയ്ക്ക് പകരം ഇവിടെ ഡെൽ ആണ് ഇടുന്നത്. ബാക്ക്വേർഡിന് കണ്ടുപിടിക്കുക ഐഡന്റിഫൈ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് ഡെൽ. ഡെൽ ഓഫ് y is you are going backward. Starting from that you are going backward. Forward എങ്ങനെയായിരുന്നു? Delta y1 was y2 minus y0, but del of y1 is y1 minus y0. Okay, മനസ്സിലായോ? So notation wise there is a slight difference. For delta you are going one step forward and going back. Sorry, y1 ആണ് ഇവിടെ. y1 delta y2 minus y1, where del of y1 is y1. So you are starting from that point going back. y1 minus y0. Second border is this. Third table clear on. I will go show the table. Table x naught values x xi. This is our xi. 0, 1, 2, 3, yi values y0, y1, y2. Del of y1. y1 is y1 minus y0. Okay. Del of y2 is y2 minus y1. Del of y3 is y3 minus y2. Similarly, second order backward differences. Del square of y2 is del of y2 minus del of y1. Del square of y3 is del of y3 minus del of y2, etc. The third order divided difference. Third order differences delta q y3 equal to delta square y2 minus del square y2 minus del square y3 minus del square y2. Del square y3 minus del square y2. Okay. Now here also the interpolating notes Google Classroom share it. You can go and write in your notebooks and learn it. Pn of x is equal to yn plus u into del of yn plus. If it is slight difference is there. For Newton's forward, you are using u into u minus 1. Here it is u into u plus 1. Del square yn plus etc. u into u plus 1. Earlier it was u minus 1. So you have to stick to this. For forward interpolation and backward interpolation, you are using different polynomials. Okay. So polynomial you have to stick on. One is u into u minus 1, etc. The other is u into u plus 1, etc. And here using del of backward operator. So you have to write two different table also. Table you have to make sure that you are using two tables, two polynomials. And here what is the value of u? It is x minus xn. It is the final value. Xn is the last value. For forward, you are using x minus x naught by h. Here it is x minus xn by h. Okay. Just a problem, just to vidam. This one and all you have just mentioned. This is also I have shared in the notebook, classroom, Google Classroom. So look at the problem. Compute the value of, this is a, so the following table gives the values of f of x is equal to e raised to 0.1x at certain values of x, and compute the value of y at f of 0.25 and y at 0.7. F at 0.25 is in the beginning of the value, so we will be using forward difference table, and 0.75 it is also here beginning then. Okay, no problem. So y is equal to f of x values 0, 1, 2, 3, 4 y values in tannittunde. Here delta y it is this difference between these two. This minus this. Difference the difference of these two is taken here. And the difference of these two is taken here. And the difference of these two is coming here. And the difference of this is coming here. Again, the difference of this is this. And there is an order, y2 minus order. Order you have to be careful. The difference of these two is this difference. And finally, you are arriving at this. Sign is very important. Appa difference nalla pole clear aaki manasilakki vekka. Okay. And for the values and the underlined one, for forward difference formula, we are using these values y naught, delta y naught, delta square y naught, delta cube y naught, and delta raised to 4 y naught, and substitute here y naught, delta y naught, delta square y naught, delta cube y naught, delta raised to 4 y naught. And what is u? U is nothing but this x minus x naught by h. What is x? The polynomial variable you are going to fix. X naught is the initial value, but here it is 0. And what is h? H is the time difference. Here h is step size. Otherwise, you can choose. Here it is given to be 0.5. 0.5. So h is 0.5. So you have u is equal to 0.05 by 0.5. It is 0.5. Okay. So substitute and get the value. This is the method. Now for backward interpolation method, for backward interpolation method, this question just a technique. Here we have to use a value somewhere here. We have to find a value like 1.80 ആണ് കണ്ടുപിടിക്കാനുള്ളത്. That will be somewhere here in between this. So we are using backward interpolation formula. So table is almost similar. X naught values, ഇവിടെ X naught values എടുക്കാം. First column. Y values here, X0, X1, X2, X3, X1, X4, Y0, Y1, Y2, Y3, Y3 variant. Then delta Y0 is the difference between these two. The difference between these two here, difference between these two, difference between these two, and difference between these two. And here, for the formula, here we are using, instead of Y0, here we are multiplying by Yn. So we are using the final values from the table. Okay, ഇവിടെ എല്ലാം ഫൈനൽ വാല്യൂസ് ആണ് നമ്മൾ എടുക്കുന്നത്. ഈ ടേബിൾ എല്ലാം വാല്യൂസ് ലാസ്റ്റ് വരുന്ന വാല്യൂസ് ആണ് എടുക്കേണ്ടത്. അപ്പൊ വാല്യൂസ് എല്ലാം അറിയാമല്ലോ. സോ വി വിൽ യൂസിങ് സ്റ്റിക്ക് ഓൺ ടു ദീസ് ഫൈനൽ വാല്യൂസ് ഓൺലി. ഇത് മാത്രം ഓർത്താൽ മതി. ദെൻ മൾട്ടിപ്ലൈ ബൈ കറസ്പോണ്ടിങ് y വാല്യൂസ്. ഇവിടെ നോക്കിയേ, ടേബിൾ നോക്കിക്കേ, ആ ഫോർമുലക്കകത്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. yn എന്ന് പറയുന്ന ലാസ്റ്റ് വാല്യൂ u ഇൻറ്റു വാട്ട് ഈസ് u, x മൈനസ് xn ബൈ x. x minus xn എന്ന് പറയുന്നത് ഇവിടുത്തെ ലാസ്റ്റ് വാല്യൂ ആണ്, വിച്ച് ഈസ് 2 ബൈ h സ്റ്റെപ്പ് സൈസ് 0.5 ആയിട്ട് എടുക്കാം, 0.5. ആൻഡ് ഇവിടെ x എന്ന് പറയുന്നത് നമുക്ക് കണ്ടുപിടിക്കാനുള്ള വാല്യൂ 1.8 ആണ്. യു ക്യാൻ സബ്സ്റ്റിറ്റ്യൂട്ട് ദാറ്റ് and simplify this. Okay, this is how we compute the values. And if you are supposed to asked to compare with the original value, you can substitute in the function and you can find out like this. Okay, now we can stop here.